Hello friends, good evening all of you. Today's session we are going to see data structures and algorithms next part. Just we are going to see one by one topic and their questions, how they are asking, so how we have to answer. So that's the thing we are going to see. So today's session we are going to see about heap data structures, max heap and minimum min heap. Max heap is very much important. We got so many questions and this one, that pattern also we are going to see today. So a heap is a complete binary tree data structures that satisfy the heap property. For every node, the value of the children is less than or equal to own value. Okay, so like this, you can see here heap data structure is the maximum heap. This is the min heap they have given. So here it has to be maximum value compared to this one. Okay, and this one is a less than or equal to. It has to be less than or equal to. It will be okay. And this is a math. So just you can see 40 here. It will be minimum value. Both are minimum values. It's not like binary search tree. Binary search tree is a parent that will come less than value is left hand side and right hand side greater than value. But here it has both values. It has to be it's a minimum value compared to this one parent node. And it's a minimum min heap is the opposite. It's a minimum value. It has to be there compared to both sides. Okay, so that we are going to see now how we are going to insert the value. If we'll get a highest value compared to this one, what are the concepts we have to follow? That we are going to see now. Okay. So types of heaps. There are two main types of heaps, max heap and min heap. So max heap, the root node contains the maximum value and the values decreases as you move down the tree. So min heap, the root node contains minimum value and the value increases as you move down the tree. So here heap operations, normally we can do insert and extract max and min and heapify. Okay. Just next one. Heap data structures applications. So here where we are going to use. So there are various applications like heaps are commonly used to implement priority queues. It's like higher priority that like that. So where elements is retrieved based on their priority maximum or minimum value. Heap sort is sorting algorithm that uses a heap to sort an array ascending or descending order, that also. And maximum the heaps are used in the graph like algorithms like a Dijkstra's algorithm and Prim's algorithms. So this algorithms also everything we are going to see next coming videos. Now we can start the work inserting this one. Construction of max heap. How we are going to construct a max heap? First step one, we have to follow, create a new node at the end of the heap. Wherever we are going to insert the value that we have to start. Suppose it's a new node, newly we are going to start means we can start from the new node. Next, assign new value to the node. Next, compare the value of the child node with its parent. If the parent is less than child, if value is parent is less than child, so it has to swap the value. We have to interchange the concept. So here, how they will ask the question, sometimes they will give you numbers, many numbers, and tell us to do inserting values, and we have to find out. And what is the left tree and what is the right maximum right tree? They will ask like that questions. Sometimes they will ask the height of the tree. What is the height of the tree? So like this, they will ask you many questions. Okay, step 5, repeat step 3 and 4 until heap property holds up. Now you can see inserting the values. These are the values we are going to insert now. Yes, now we can see one by one. Just I'm going to write here because it's a tree model. Just I'll show you and write and I'll show you. First one, I'm going to write 35, I have to insert. Yes. Next one, 33, I have to insert. This is a minimum value. That is not a problem. That's over. This also over. Now 45 it has to insert. So now 45 has to insert. So what will happen? This is the highest value compared than root value. Here again 26 and 31 also is there that I have. Okay. So 45. So what happened here? It has to swap because it's the highest value does come. So what happened here? I will write 45. Now 35. This one 33. This is 35. I got it. Now okay. Now next one. Next level by level we have to insert. Next 45 over. Now 10 has to insert. Now 10. 10 it will be no problem because the smallest value compared than parent. Next 14. So 14 what happened? So I'm going to insert here. Here also it's not a problem. Now 19. Just 19 you can insert. Here also it's not a problem. I got minimum value. Now 27. So 27. It's okay. Next one here I got 45. Sorry, 44. So here I will get a problem. So what has to do first? This one I have to interchange this both values. Okay. So separate we have to make, otherwise we can make it in the same tree only. Just I will make it to some colors and I'll tell you how we are going to do. So this one we have to make it 10, then this is a 44. Yes. Now next one. So what happened here also 33 and 44. So here also I have to do the correction. So here 44 I have to interchange this one. So here 33. Okay, now I got. Now next one. 27 I'm going to, 26 I'm going to insert. So where I have to insert? Where's here 26 I have to insert. So it's not a problem because here 33 only is there. So no problem. So next one 31 I have to insert. Here 31. Here 31 means automatically I'll get a problem because here minimum value, here maximum value. So here I have to change again. So what I have to do? Here it has to red white 31 it will come here. Here 14 it will come. Yes. Now just you can check it. What is the answer? First one 45 we got. Yes. Next one 44. Here 35. So next one here what happened? 33. Here 31. Here 19. Here 27 we got answer. Okay, next one here what happened? Here 10. And here 26. Here 14 we got answer. This is my answer actually. So how they will give the answer actually? 45 they will give you, 44 they will give you, and 35 like this we have to write level by level. That's all. So 33 and 31, just 19, 27, then 10 and 26 and 14. This is my answer. So 4 answer they will give you. They will also this answer we have to select. So previous year question also we are going to see how they are asking questions. Okay. This is just insert model. So next one we are going to see the delete, how we can do deletion. Next we can move on to the next slide. You can see max heap deletion. So here first one we have to remove root node. I'm going to delete the root node. So move the last element of the last level to root. So compare the value of this child node with this parent. So next one, step 4, if a value of parent is less than child, we have to swap them. The same format which you have done in the insert concept. Next one, repeat step 3 and 4 until heap property holds up. Okay, now we can see how we can do deletion. So deletion, I'm going to do the same trick, little bit different. So what happened? I'm going to take 42. I'm going to take 40 and 35. And next one here, I'm going to take 33, 31, 33, 31, and 19, 27. 19, 27. So next one, I'm going to take 10, 26. And 14 I'm going to take. Yes. So what I'm going to do now here, I want to delete. This is 42 root node I want to delete. So what has to, first step I have to follow. So last node, just you can check left side or right side. Which one is the last, this one. That we have to move to the root. Now what happened? I got 14. So next one 40, 35. I have deleted just 42. Okay, now 33, 31 I got, and 19, and 27. Yes, next one 10, and 26. That's all. The 14 have just have taken and have returned as a last as a root value. Now this is my value, but now you can check it whether it's correct. It's a max heap or not. No, because it's a small value compared to this values. So I have to change. So maximum we have to practice within the tree, because we will get some rough papers only. So if we'll do so much of papers, automatically it will be tough for us. So here only we can try to work out. So I'm making it a color, some colors. So what I have to do, this actually this page, this left side I've taken. So I'm going to move left side only. So this 40, I'm going to take 14 here. I'm going to write here 40. First it will be over. Now 14, you can see here 33 is there, but this is also wrong. So what I have to do, here I have to write 33. Here I have to write 14. Yes. Okay, that's also over. Now here 14, 10 will be okay, but 26 is the highest value here. So what I have to write, 26 I have to write, here I have to write 14. Now I think I have done everything. So now what is the value? My last value 40. So I have to put everywhere this is around, but I didn't do. So here 33, here 35. Yes, 35. So next one here, what is the value? 26, here 31 and 19 and 27. So next one, what happened? 10 and 40. So what value for my, actually my value 40, 33, 35, 26, 31, 19, 27, 10 and 14. So like this, we have to do the deletion operation. Yes. Next, we can see the questions, how they are asking. Now, the element 42, 25, 30, 40, 22, 35, 26 are inserted one by one in the given order into the max heap. So the resultant max heap is sorted in an array element as what we have to. So we have to work on what we have to do. So again, I'll tell you the same model, 42. So 25 I'm writing. Here I'm writing 30. So it's not a problem because it's a small value compared to this one. Now we can insert 40. So automatically 40, I'll get a problem because it's a highest value it has come. So I'm going to change. So here this just we can swap it. This is 25. So this is 40. Okay. Now we can see this is over, this is over, this is over, and 40 also over. Now I'm going to do 22. 22 is not a problem. So next one 35. So 35 automatically I'll get problem because this is the biggest value. So again, what we have to do here, I have to do 30. Here I have to change swap and 35 we have to do. Just we are going to make a swapping. Okay, next one, last one, 26. So what is my resultant value? 42. Here 40. Here 35. Here 25 and 22 and 30. And 26. Just you can check it one first value 42, 40, 35, 25, just level by level 142, 40, 35, 25, 22, 30, 26. So first answer will be my answer. Okay. Sometimes they will ask you what is the height of the tree. And sometimes they will ask the order everything. They will change, and they will ask something different question. That I'll show you how they are asking. Now you can see consider an array. So here, this one they have given. So 4, 1, 3, 2, 6, 9, 10, 14, 8, 7. So actually in this question, they've asked what is the height of the array and what is the right maximum value. What is the height of the array and what is the maximum right value. Okay, now we can check 4. So 1, 3. Again here, what happened? 1, 3, okay. Now we can just put 2. So this one over, this over, this over. But 2, while doing 2, it will be a problem. So I have to make it here 1, here will be 2. Yes, now 2 over. Now we can put 16 here. So automatically 16 will be difficult. So again, I have to change here. So what I'll do, this is 2, this is 16. In 16 also, I'll get a problem because this is a 4 minimum value. So here 4, here 16. Okay, so up to here I have done. So next to one 9. So 9 also, so I can't do that. This one 3 have to interchange. This is one 9 it has to come. Next one, you can make it 10 here, 10. So 10 will be its biggest value. So again, you have to swap. So here 10, here 9. This over. Now 14. Now I'll write this one. It will be a little bit confusion. Just I'll write once again. Now 16. I got now 4. And here I got 10. Here I got 1. Here 2. Here 3. And 9. Just now up to now, I got this values. Okay, now we can do 14. So where you have to do 14, here I have to do 14. So automatically I'll get up this one, it's the highest value. I have to change it up. So what happened here, I will change this value. Now you can see this one is a 1, this one 14. So again, it's the highest value. So this one 4 it has to make, this one 14 it has to make. Okay, so that's all. So next one 14 over. Now 8. So 8 means this also here 4 value, here 8 value. So here 8 is has to come, here 4 it has to come. Okay, this 8 over. Next is 7. 7 also highest value. So 2 it has to come, here 7 it has to come. Now just final heap value I will write here. You can see, check it. 16, 14 and 10 and here 8, here 7. Here 3 and here 9. Okay. So next one, what happened here? They have written given here I have made a 1 and this is the value 4 and this value here 2. Yes, this is the my inserted value after that insertion. So what is the height of the tree? So 1, 2, 3. So my height of the tree height is just 3 value. And that so right side maximum number. Just I didn't write the question here. They're asking, they will ask the right side maximum number. Okay, right side maximum number 10. So 3, 10 is the my answer, this one. So like this also they will ask you questions. Sometimes they will ask you how many swapping has done in this question. Maybe 3 swapping and 4 and 5 swapping, whatever. So like this also they will make ask the question. Sometimes height and swapping and what is the total value, full value we have to present. So number of variety of questions we will get from Max Heap. It's one of the important question. Okay. I hope it is clear. Okay. Thank you all of you. Thank you once again. Next, we are going to see pre-order, in-order, post-order, and threaded binary tree. Actually, threaded binary tree also one of the important question. But before that, we have to see this is a in-order concept because through in-order only we are going to do threaded binary tree also. Okay. So for the next video, we are going to make it pre-order, in-order, post-order, and how we are getting questions for NET, as well as it will be very important for TRB also. So TRB also it's very much useful. Just you can refer it. Thank you once again, all of you.